Okay, good morning. Welcome to
FamilyMath380.
FamilyMath380. So today we're going to do a neat project I saw in our book, Count Like an Egyptian. And we've done a couple projects like this from this book before, not like this before, but from this book. One of them was learning how to multiply. Do you remember how the Egyptians multiplied?
No, not really.
No? Okay, well, maybe we'll revisit that project because it was actually pretty cool. But I opened up this book just the other day. I was looking for something else we could do, and I saw this project about pyramids. So why would a book about Egypt have pyramids in it?
Well, Egyptians built a lot of pyramids.
Egyptians built some pyramids. And it's kind of a cool looking project about the volume of a pyramid. So we're going to approach this a couple different ways. And this is also something that we've done before in other settings.
Yeah.
And so here's my question. We have a pyramid, a square pyramid,
Yep.
like this. Okay. And we want to compare the volume of this pyramid to the volume of a cube whose square sides are all the size of the base of the pyramid. So do you see that? Do you see that square?
Yeah.
So it's this. The square is this big, or is it a cube or a square?
We're going to compare the volume of this pyramid to the volume of a cube whose square sides are the size of the base of the pyramid.
Well,
So-
I think here it would be 1/6
Okay, how come?
because so if you can imagine like this point is the center of the cube,
Uh-huh.
and then so you can imagine stacking one of
Sorry about that. I think there's a squirrel outside.
So you stack one. You put another. You take another one of these shapes, and you put this this triangle shape on here, and you keep the square faces to form the faces of the cube.
Okay.
So and each of them has one face, and there's 6 faces on a cube, so that'd be 1/6.
Interesting.
Well, I have a slightly different way of doing this.
Okay.
So I recognize these. We did a project about folding up into cubes.
Uh-huh.
So I recognize these to be able to fold up into a cube, sort of like this.
Interesting. Okay.
So then this is going to be an eighth of the cube that we want.
Can you let go of that so the camera can see it? Okay, that's going to be an eighth of the cube that you want. Okay.
And then,
Why is that, by the way?
well, because it's a 1 by 1 by 1 cube,
Okay.
and we want a 2 by 2 by 2. You can fit
Interesting.
8 of these inside a 2 by 2 by 2.
Okay, you could fit 8 of those inside of a 2 by 2 by 2. Okay.
And then you have a third of an eighth, so you have a 24th. These are each the volume of these pieces are each a 24th.
Uh-huh.
Then you have 4 24ths or 1/6.
Very good. Very interesting. And there's one other way that we have to approach this same problem. Do you know what it is? That we have in this house to approach this same problem.
Oh, the Zome set.
Yeah. So why don't we do it with our Zome set, and let's see if we can build these shapes and assemble them into a cube.
Okay.
All right.
Okay, let's see if there's 24 of them. All right, high five. Good work with these guys.